Section 9.2 is about arithmetic sequences. We're going to define, identify, and apply sequences. It should be apply arithmetic sequences. An arithmetic sequence is a sequence where the difference between consecutive terms is the same. So the difference between the first and the second is the same as the second to the third, is the same as the third to the fourth. When you're doing those common differences, they do have to be in order. The common difference is that difference in an arithmetic sequence. There are two different definitions. The recursive definition, your first term is a. Your nth term would be a sub n minus 1 plus d. Remember, d is that common difference. N has to be greater than 1. And remember, n is like the number of the term that you're looking for. So if you were looking for your 100th term, it would look kind of like this. So your n is 100. So you're looking at a sub 100 minus 1 plus d. Well, that simplifies down to this. I usually don't write what I just wrote. I'm looking at this one. So you have your 100th term that you're looking for. You're looking at the previous term, which is the 99th term, plus that common difference one more time. So just a little FYI about how those n and n sub 1s work. The n sub 1 is just the previous term. The explicit definition is a sub n equals a, which is your first term, n is the number of terms, minus 1, d is the common difference. So when we're checking to see in problem 1 if the sequence is an arithmetic sequence, you subtract. So 6 subtract 3 is 3. Excuse me. 9 subtract 6 is also 3. 12 subtract 9 is also 3. And 15 subtract 12 is also 3. So if those numbers all match, that's what the common difference is. If they don't match, it is not an arithmetic sequence. So when you subtract these two, 4 minus 1 is 3. 9 minus 4, though, is 5. 16 minus 9 is 7. And you can see that these numbers are not all the same, so there's no common difference. 25 subtract 16 would be 9. No common difference. Not arithmetic. Okay, let's look at one more. This is the practice or the got it question. 4 subtract 2 is 2. 8 subtract 4 is 4. 16 subtract 8 is 8. No D, not arithmetic. Now, how do we find specific terms? We would not want to do each term one by one till we get to the 100th term. So we're going to use those formulas that we had at the beginning to find out what the 100th term is. So we first start by writing a sub 1, which is 6. Okay, we're looking for the 100th term, so that looks like this. Okay, so our n is 100. Okay, if we use the explicit formula, it looks like this. Okay, so we're going to try to fill in each member of that. Okay, so A is 6. Or no, we haven't found the common difference yet. Common difference is 5. Okay, so we have 6, which is our first term, plus our common difference, which is D, and our 100 minus 1. So 6 plus 99 times 5, our 100th term is 501. Here I would like you to give me what those numbers are in the formula, as well as what the answer is. You don't have to show much more than that on this one. Here's a little bit different question. We have a sub 1. Here's a sub 2. We don't know that one. We don't know a sub 3. And here's a sub 4. So they want to know what are a sub 2 and a sub 3 if the common difference is something, that we don't know. So a sub 1 is 100. If we write the formula for a sub 4, it looks like this. So we have 100 plus 4 minus 1 times the common difference. Okay, so here the only one that we do know is what that fourth term is. So we're going to take that and substitute it in right there. So 82 equals 100 plus 3D. So we subtract 100 from both sides, and we get negative 18 equals 3D. And we divide by 3. D is equal to negative 6. So when we look at our terms, 100 is the first one. We're going to subtract 6 from that because that's what the common difference is. So we get 94. If we subtract 6 again, we get 88. And if we subtract 6 again, we should end up on that 82, which is the fourth one. So these two right here are the two that we found. And remember, it's just 100 minus 6, and then 88 minus 6, and 94 minus 6. So we're taking that common difference and we're putting it in there. We're going to do one more like that. Here we have a sub 1 is 80. A sub 4 is 125. So the fourth one is the one we start with the formula. First term is 80 plus 4 minus 1 times our common difference that we don't know. We do know a sub 4, it's 125. So I'll subtract 80, and we get what, 45? Equals 3D, and we divide by 3 and get 15. So this is an increasing sequence. So you're going to add 15 to every term. So the first term is 80. The second term we don't know. The third one we don't know. We're going to know very shortly. So 80 plus 15 would be 95. And then 95 plus 15 would give you 110. And then 110 plus 15 should give you this one, which it does. Okay, so that's how you find missing terms within a sequence. Now, on the next page, they're talking about arithmetic mean. We have talked a little bit about this before in geometry. It's just taking the average, so you're adding your two terms together and dividing by 2. So it says, what is the missing term of the arithmetic sequence of 15 blank 59? So the one that we're missing is right here, and if we're only missing one in the middle, you take and you average them. So 15 plus 59, and then divide by 2. So 15 plus 59 is 74, and then 74 divided by 2 is 37. So your missing term is 37. When you're looking at this one, you could find the common difference after that if you needed to. So when they go in the order of 15, 37, 59, if you subtract the 2, you'd be able to find the common difference, which in this case is 22. If you add 37 plus 22, you should get 59. So if you ever had to find the common difference from that, you could very easily. The 9th and 11th terms are 132 and 98. So we add the 2 and divide by 2. And you get 115. So 132, 115, and 98. If you find these common differences, they should be the same. 132 minus 115 is 17. And then 115 minus 17 gives you 98. So that kind of gives you the common difference and how to find them.